This chapter contains information on very large-scale transformer and applications, so I will only concentrate on a few smaller topics. Whenever center taps appear on the secondary, they cut the output voltage in half. In this case, 24 volts is at the secondary, but then between each terminal it will be 12 volts. In the case of multiple taps on the secondary, the letter X is used to denote each individual taps. Then each individual will have several different turns ratio. The secondary taps can be connected in several ways. In this case, they are connected in series, and in this way you can produce the maximum voltage which can be delivered to the load. Here the secondary taps are wired in parallels so as to provide a lower voltage but higher current to the load. And there should be an X4 at the bottom, which I left out by mistake. Taps on the primary windings are indicated by percentages. In this case, the 10% tap would take out 10% of the winding. Therefore, the turns ratio would be 9:1 instead of 10:1. So the output voltage would be 1,000 volts divided by 9, which equals 111 volts. This would be higher than it would be if you had used the entire primary windings, which would have been 100 volts. An auto transformer has only one winding, and even so, depending on where you put the wiper, that you can get above or below the primary voltage. But the problem is that the neutral wire is shared between the primary and the secondary side. Because the neutral wire is shared between the primary and the secondary, because there's only one winding, that means there's no true isolation between the primary and the secondary side. So if a break should occur in a winding as indicated in the drawing, then the full voltage of the primary will be applied at the load and it will cause damage to the load. Large-scale electricity is generated in three-phase generators where each generator puts out three separate sine waves, and then the generator could be wired in a delta or a Y. And so the object of this chapter is to see how three separate transformers are used to go between the two connections and also to be able to step up and down the voltage and send the voltage many miles down the line from the generator to the user. For the purpose of our class, the most important concept of this chapter is to understand the relationship between phase voltage and line voltage. Phase voltage is the voltage across one coil, whereas line voltage is the voltage across two coils. Then there is a formula. Make sure you understand how to use the formula and solve problems involving three-phase generators.